Good morning, everyone. Welcome to class and welcome to week 5. We are going to be wrapping up the discussion we started on wrangling, and that was what we did last week. And so today will be the last discussion around this topic, and it is going to be a little bit of a lead way to what the rest of the week will be. The rest of the week is going to be on visualization. So I am going to be starting off now, and I have tried from last time. There was something I tried to play. It didn't play out well, but there was some music I was trying to play now, and it didn't come out well either. But I have tried a couple times, but I have learned from somebody what I could do next time. So we'll try out, in our other version. It's a Monday, and I'm going to start talking about this topic, and we are going to be working around code essentially today. And so before I get started with that one, I want to point out a couple things and allow people to come in on board. So the usual thing we do when we get started is to have a warm-up question. And the warm-up question for today has nothing to do with the topic we discussed. We have had a pattern a little bit before, but this time we don't have a question that is related with the topic. And it's going to be a longer question, so I'm going to ask for somebody who would be able to write this one out. And the volunteer, the person I pick for today will be Morgan Kelly. And when you're ready, you type up the question. I'm not sure how many of you watched the Emmys yesterday, but there was Emmys going on. So I'm going to have a two-part question. The first question, part of the question is whether you watched. You might have watched, you might not have had the time to watch. So watched. And then the second one, this is like what we did like vectors when we were learning about R, where you have 2 or 3 things to say. Now you're going to say 2 things, watched or not watched. That's part of the answer to the question. And the other is, I liked it, or I was happy because, and then you fill it, because your favorite person won, or whatever it is that you want, or you like the format they went also online, like we do, and like, with all these things. And so say watched, and I was happy because, and you finish. And then you say watched, I was disappointed because, you say it. And if you're not watched, you don't have any other thing to say, you say not watched. So it's a complicated question, and Morgan, I'm sure, will be up for the job. Type up the question. It says, did you watch the Emmys yesterday? And were you happy or disappointed? Something like that. Formulate something like that. That will be a good one. And everybody participate. That is the warm-up question for the day. You did a good job last time when we had an invited lecture, and I was interested or intrigued by the kind of things you chose for health metric. Someday you may come back and try to see some of these things that happen that we do and try to reflect on them and write about them, because I was curious. Some of you wrote some things that I would have liked to have a conversation around, but we don't have the time for it now. So the purpose of this slide is just this slide, and it's a good reminder that we are in fall. We are in week 5. We're going to wrap up wrangling, but the rest of the discussion is going to be around things that are not on slide based. In fact, I'm going to be using code. So while you tell me about how the Emmys went yesterday in your view, if you have watched them. I'm going to ask another volunteer. This time it's going to be Chris, because he has done a great job last time. So I'm going to stop sharing for a second, and I'm going to ask Chris to take us to Blackboard. And so you can share the screen for a moment. I'm hoping Chris is around. I've not checked whether he has come on board. Yes, he is there. So he has done a great job last time. And so I'm going to rely on him again for today. So go please to the class's website. And so I want to point out a couple of files that are posted under today's lecture. That will be the first thing I want to do. So please go to content, lectures, and today's date. Perfect. So I'm going to I have told you last time, we will have, depending on what we are covering, different things pointed out for each lecture. For this one, the best way for me to have you this, and for the best way for you to get the material I want to get across, is by looking through codes. And so we're going to have two things to do. The first is to wrap up a discussion we started around data wrangling, data manipulation using DPlayer. And so you may remember before Stephanie's guest lecture on Monday last week, we had started talking about data manipulation, and there were 4 verbs we finished, and summarize was the one that was left. So I want to pick up that, as I told you. And so that will be the part that says data manipulation using DPlayer part 2. I have got 2 files for this. I've got the source, the R Markdown file, and I've got a PDF. I'm going to open the PDF just quickly so that people would know. If my time allows today, this is like typed up notes, and I will walk through this, but I'm probably going to be using mostly the R Markdown file because I want to run things. But you've got a typed up note in a way, and if you want to read around this one, you could do. So the purpose of this one is to finish the discussion we started on DPlayer, and we'll come back to this file when I share and talk around it. But it would also be an opportunity for us to see other functionalities that are available in R. Like you have seen in many other things that you have done when you learn a programming language. If you were to go through all that it has to offer, it will be a course on its own. It will be a big topic. But I want to use this opportunity to point out functions, things that you would use that are not necessarily about data manipulation, about data wrangling, but that are useful to explore data, right? And so there will be some functions, some examples I would be using. So close this one and go to the other one. The other topic, and I have warned you, the relational, you could open the Word file. This is for variation now. So I have an R Markdown file, but yeah, I guess you will succeed in opening the Word file eventually. If it does not, okay, so it's okay. So it's a Word file. Yeah, perfect. This is also generated from an R Markdown, but it is in a Word format, and I'm going to be using it. Genuinely speaking, this would have been 2 lectures, but I'm going to jump them. If you remember, on the end of week 3, we had a discussion about the data science process. I said, there are topics coming up now. Be ready, buckle up. We'll be driving fast. This is why we'll be driving fast. I am confident that if I walk through and I make the point that I want to make successfully with the time we have today, perfect. If not, there isn't going to be too much of a difficulty for you to read through this material yourself. Okay, so you saw 4 files, but don't be overwhelmed. There are only 2. And essentially, one is a wrapping up of a topic that was started. The other one is, you can stay for a while there, Chris. And the other one is about relational data. And I will tell you why relational data is an important topic for us to discuss. Okay. Before I let Chris go and start our discussion, I want to stay on Blackboard and point out one thing about assignment 3. Assignment 3 is due on Wednesday. I know some of you have done and have submitted, but there was a question several of you have asked, and Helen had posted an announcement. If you go to home and where the announcement is, Chris, that would be perfect, where there is a clarification. The point of this one is related with question 2 of that assignment. Question 2 of that assignment is built on a case study. The case study was taken from the R for Data Science book. That book is available online. One thing is a complete footnote. It's a complete side note about a good thing about a book that's online is it leaves dynamic. It is something that people can update, and in this particular case, it was not something we knew about, but there was an update made to that case study that made the question no longer relevant. And Britt pointed this one out to us, and we looked at a few other students who have asked the same question, and so Helen had posted Friday, very late night, what the issue was and how you can address it. The modification that was needed was not much, but the instruction that you were given was outdated because of some other things that have happened. So the book, because it's online, was updated, but the question was not. If you have submitted, no worries. You're out, a few of you. It's not going to change anything conceptually or what we wanted to assess and what you wanted to practice on. But for those who have gone through it, you will know what the problem is, but it is fixed. Make sure that you read Helen's post, but it's a short one here, and also the updated assignment. So it's, points and things have changed a little bit, but the rest of it is the same. So make sure that you do that and make sure that you submit on time on Wednesday so we can say this discussion is wrapped up. Thank you very much, Chris. And you can now stop sharing so I can go to sharing my screen. All right. I'm going to start first by seeing how far we can go. And I'm going to look at your reactions to the MEs later on, and you will hear me have a summary of it. But let me try to see if I can do with the R Markdown file. And if we kind of want to go faster, then I will switch to doing without using R. So let me see what I can do. Can somebody give me a thumbs up or indicate somehow whether you are seeing the R Markdown file? Okay, perfect. Okay, so let me try to go through this. I hope this is big enough, but you've got, as I pointed out, you have got the PDF file and also the the source code that you can follow along. And be ready for me to just sometimes actually run the code, sometimes I try to explain it. So what were we doing? So we are looking at DPlayer. I should have asked Chris one more favor while he was sharing his screen, but let me talk through it while I'm here, and you will be okay. For a second, I'm not sure how easily you can do it. You could go to tidyverse.org and see whatever it is that you see on a browser. So let me give you a chance to do that. I'm not sure, some of you may not have enough of things to open and see, but that's a place where you could find some useful information and do it later on. So you'll see packages. One of the packages that you know is DPlayer. TidyR, the one we talked about using how TidyR, is another package, but there are four other packages that are included. This is a collection of packages that are written using the same philosophy. And this is written by the same person who wrote DPlayer and the chapter that I mentioned in the R4 data science book and the book itself, right? Hadley. And so there is an advantage in working with it. And this will be an R Markdown file that uses it, or this discussion and the relational data discussion would also use it. So I want you to be aware of it. It is a library that you can download or you can make use of, and this discussion will make use of it. So if I had Chris on board and was sharing, you would have gone to the tidyverse.org webpage, and then you would have seen these packages and how they are organized and a little bit of description around them. But you can do that on your own. In fact, that's the suggestion I have for your lunch break today. I am not a big believer in multitasking. When you eat your lunch, don't do other things. But if you could have another half an hour or something that you can spend, make sure that you be working with this material and looking at those and browsing those things today, so that you have this available for you. And when we start doing things and project and so on, you don't have to come back and learn about them. So orient yourself about it. Tidyverse is the name of the library. Okay, so last time we saw these 5 verbs: filter, select, and arrange. That arrange one was the one that would change the order of rows in a data frame, basically. We didn't talk about it, but mutate is an easy thing. It's a way to add a variable, but summarize was the place where we stopped. And so I'm going to pick up a discussion from there. If you remember, the discussion, the R Markdown file we had done was based on a data set that was about flights from Houston. And that was called H flights. For the discussion I have here, and because I want also to show you some other related things that are richer in terms of what they have, we're going to be using the same essentially type of data, but this time it is from New York. And this one is called NYC flights, and it's NYC flights 13, and that's because it was 2013. One of the reasons I like about this data set is because it's going to bring us to the relational data topic that I will talk about now, where is the reality where you normally, when you work on things like have with data, you will have to tie them with other things, tie them with other data that is somewhere else, and so get information from here, get information from that type of thing. And this data set has that connection, and that's the reason for it being chosen. Okay, when you do this R Markdown on your own, you will notice that it will not be exactly the same as I have. I will run codes and you will see results and things like that. In your case, you may get some complaints. And so R may say you haven't installed the latest, or you have to install this package, and so on. So when that happens, be patient with it, walk through it, and depending on the system you have, you will succeed. But everything that you see on my end here will successfully run because I have updated. I don't have the very latest R, and in some cases you may see warnings that's different from what you would see. And so don't get puzzled by that. And so work with it. And if you need help, make sure that you get that help, for example, by going to Helen's office hour on Tuesday. All right, so NYC flights is the data set. Tidyverse is our home for a package, a series of things that are opinionated is what Hadley calls these ones, because they say you have to insist on, and a function has to be a verb, and it has to have all this syntax and so on, which is good thing to a good practice, but it is also something that you could sometimes find it opinionated, as he says, really. And so that's that collection. And so we are going to, let me just run this. And when I run this, you would see that I get the data sets, and it looks like this. And remember, this table, as it is called, is a data frame that has got a nice printout. And so this is the nice printout. We've got year, we've got months, day, departure time, schedule time, and things like that. That's what the data looks like. Head is a way to explore a data frame, like in this case, flights. And so you are looking at a portion of it, 6 rows in this case, with 1 to 8 columns of 19 columns. Those columns now we know the words are called variables. Cases, the observations are on the row. This is tidy data, by the way. And so there will be some places where some information may not be available. So NAs, and we deal with them, but otherwise it's a tidy data. Okay, so the next thing I want to show you here very quickly is that variable called mutate, which is a way to introduce a new variable, the thing that was not there. And this is easy, but one thing I want to immediately tell you is you can work with it just like any other variable that was already in your data frame. The only difference is when you say mutate, it does not get added into your data frame automatically. You get it, you have got an exposure to it, you work with it, but it does not get added into your data frame. For those of you who know relational databases, this is more like a view. So you're taking a view, but the original one hasn't changed. And there is a way to change it, and I'll come back to it in a second. But this mutate now is going to maybe first, we do a selection out of the entire data set, something we call smaller, and we are going to select, and now you know what select does, three of the columns out of it. Year, today, this is just a continuous block of things, and we are going to find everything that has delay on it, and we are going to have now this distance and arrival time picked up. That's our selection. And then we are going to apply this mutate verb on the reduced data frame that we just calculated, and are introducing 2 new variables called gain and speed. And you see how they are calculated. Departure delay minus arrival is what gain is, and speed is distance divided by time, and it is multiplied by 60 because we want to change it into a proper unit. So when we do that, now we have this gain and speed added into our data frame, and this is the result that you would get. You could use the columns that you just created to work further with them. And so, for example, in this case, we have this gain per speed to be defined by already introduced new variables through mutate, and we get the same result like what we have done now by using them. If you only want to keep the new variables and not the old ones, because you are interested, usually when you do these sort of things, you would be interested in the new ones because the data frame itself was there, and it is most of the time not something that you want to display or interact with or to show your colleague or report something on. The actual ones that you have actually extracted out are the ones that you may care about, and that functionality is available through this function called transmute. And when I do that, now I've got the hours and the gain per hour displayed in this fashion. Okay, this is the place where I am going to be walking fast and be ready. Coffee drinkers, make sure that you have had your coffee. So this is a place where I would list functions. And there's no way to learn. You don't sit down and study a computer programming language manual and see all the functions that are available and so on. So you will know about them when you have the need, but sometimes a quick reminder like this is helpful, especially if they are categorized in some fashion. So some useful functions, things that are, working with arithmetic operations is something you know, but the modulo operator is something that you might have seen before. Sometimes you care about just the remainder. What I want to point out to you here is how the syntax looks like in R. And so the integer division and the remainder is how you see this. Other collections of functions, you've got a bunch of different kinds of log functions, base 2, base 10, and when the base is not specified, it's the natural number. That's how R would do. And then there is something they call lead and lag. And these are functions that would be useful in the context of a data frame, which is almost always what you have. So sometimes you may be interested in knowing what is immediately before and what is immediately after. That's what this lead and lag functions would tell you. Actually, they are among the useful ones beyond what you would normally expect with arithmetic operations and functions and things like that have to do with data. For one thing, they could be used in, for example, filling out missing values. For other thing is you may want to use them to discover patterns around things, for example. You've got a bunch of things that are about aggregation and cumulative values. And again, the important thing here is to know what they are called, the function names. And so the cumulative functions have got this prefix, cum, C-U-M, and then you've got sum, you've got product, you've got minimum, you've got maximum that DPlayer provides, or R, standard R provides, and DPlayer also relays them. But DPlayer has, in addition, something called cumulative mean, and that's not in standard R. Okay, so if you do something like this, then you will get results. For the purpose, I have to just illustrate this one very, very quickly. We don't need to go to New York, and with that flight, we could just work with a simple vector that has got 10 values in it, and we'll call that one X. And I'm going to demonstrate what this one would show with this little code I have here. X has got values 1 to 10. And so, you see what lag does, you see what lead does, you see what cumulative sum does, and you will convince yourself that R is doing the right thing or DPlayer is doing the right thing here, because these numbers are small and you can verify them, but trust me, they are doing just fine. And then you see what cumulative mean would does. Okay, some reminders, some functions, some things that you would run into. Many things would also require logical comparisons between two things, less or equal to, equal, greater, and so on. Again, these notions are very familiar to every single one of you. What you need to know is what they look like in R and what symbols you would use, and they're not surprises. Most of them are what you would have expected. The not equal to has got an exclamation mark before it, and that's how you would write it. Otherwise, it's much like what you would see in other ones. And you have a way to rank in descending and ascending order, and that's kind of illustration for that type of work that you see here. Okay, now is the actual part where group by comes, or summarize comes, the fifth verb. And this has to do with something that you can apply on, you will summarize them, you would bring them to one value, but after you have grouped by something. And this is what I would like to illustrate for a second now. And so we're going to be going to the flights data set to show you how this one works. I hope this is big enough for you to see. And so we first, to apply summarize, usually you first need to group by a certain thing. So for example, in this case, we want to group by the data set by flights and year, month, and date. So that would define a flight that has happened in a particular year and a particular month and a particular date. After we have taken this, so for this particular day, then we could be interested in many things. For example, we might be interested in finding out the mean departure delay once things are grouped in this way. And so this is a very convenient one. There are 2 lines of code you have basically written, but you've gotten a lot out of what you wanted to explore with this data if you were to report around this or if you were to study. And you can imagine, now we called it flights, but you can imagine what kind of data set you might have that you may be interested in. So we're looking out of all of the data set that we have, flights, and we have grouped them by flight, day, month, and year. So we've got one particular day. And for that day, we're going now to summarize by computing delay. And what you do when you supply the syntax for summarize. So the group by would give me the data frame, that's flights, and then whatever it is that I want to group by will be the variables I would specify, and I would list them by commas, which means, and I'm going to use all, this ones is what it means. And so I have given a name for that selection, that grouping, and it's called by day. And now the summarize is applied on it, and what is given next is the function to be applied for this one. And in this case, we're going to do a variable called delay, and the variable is going to be a mean of the departure delays. And because we are computing, a mean, we have to decide what we are going to do when values are missing, and in this case, we're going to remove them, and that's what this would tell you. So when you do this, you get a result like this. So you can see now things are grouped, and you have a column that's added that's called a delay, and this value is a mean of the departure delay. You could write what I just wrote within the thing that we learned last week, but you've seen many times since then, this operator, the pipelining operator, to make the code readable a little bit. And so you could see that being used in what we are going to do now. The piece of code that I show you next, and some of the things that I will show you afterwards, will also introduce a few functions that are available in R that you may be wanting to be aware of. Sometimes, and this is a reminder, some of the names that you see in R being so short could also be confusing. For example, there is a function called n, of all things, just n. And it has got a parenthesis around it. What it does is it counts. It's a fine thing, but I probably would be, it's not a usual thing in other programming languages to find a function that is just something like this one. And in part because it is a language that is, for data analysis, and you've got a function call, and you've got certain things to give in parentheses. Maybe the brevity would help fit something in one line, and so you could argue for it, but this is not something that I find extremely convenient. But it's a function name, and what it does is it would count. So here we have a piece of code that would go to the group by, which we just did, and now this time we are going to group by destination, and we are going to now do a little bit of calculations. Delay, and this delay is going to summarize by this destination, and it's going to first count and then compute distance by having a mean, compute delay by having a mean, and then we're going to filter this. So notice now we are using multiple of these DPlayer function calls, and after having grouped this one, we are going to look for the place where there is a lot of delay, so where the count is more than 20. So we have calculated this, but we wanted to see if there are enough of them, most frequent ones, for example, let's say. And so for that reason, we needed to count the incidents, how many there were, and we called that function n, and the variable we stored this one in is called count. And so after all of this is done, this is going to give us some results. And the piece of code here is also a way to demonstrate something that if you have followed Helen's tutorial on graphics, you might have heard her talk about ggplot. You might also remember Stephanie mentioned ggplot. She says she likes it, and they do it every day in the place where they work. So it's a nice visual, and it's a nice way to display things. And so spend some time to see what I'm doing there. But the product or the visualization of this one is what is going to help you. So there's quite a bit that has gone through this piece of code, and I know I'm going fast over it, but I think you will see. So there is some calculation that has happened, there is some counting that has occurred, and there is something that we have chosen out because we want to find out the ones that are the most frequent ones where the count is greater than 20. And after we have obtained this information, we want to plot and see what it looks like. And I'm going to be just doing that now. And here is what it looks like. The gplot result now shows you and how this, are distributed. If you go back to the code, you will see what the delay is and how much distance it has traveled. A side note, it looks like, as this distance are in miles, and this is about flights. And so you have taken the mean and looked at these things. And so the plots that you see here, the different circles show you how many there were with that much departure, with that much delay. And so when there are many, we counted the ones that were above 20, and so below 20 were not displayed here, but above 20, you could have many, many things. And so some of them are 100, some of them are 500, some of them are 16,000 and things like that. So we'll get to visualization, but this is a nice way to visualize something in a two-dimensional space where you actually also want to show size. So this delay versus distance display would show you how much delay there was, relative to how the flight's distance was. And it also shows you how many of them there were. And so there are so many things that are displayed right in this visualization. A good appetizer for the visualization discussion that may come, that will come starting from Wednesday now. But the point here is there is a trend also that you see. And that trend is there is more and more delay until we get to something like 750 miles or maybe something like 800 miles, and then starts to go down. And that's kind of curious. So maybe when there are very long flights, like flights to Hawaii or something, then you have, because of the distance, you've got a way to make up for the delays. But the relatively shorter ones, there is delay that kind of increases with distance, is what this data do. This is not, you can investigate why this might be the case, but this is what the data shows. The New York flight in 2013, things might have changed since then. But that was what I wanted to show you here. The code I wrote earlier could be written a little bit more legibly if we use the pipeline operator. So then, so we got delays, then I do this, group by, then I summarize. And so that is just a demonstration for having to show you to write this one a little bit more legibly. Okay, speaking of functions, there are also more summary functions we could use: mean, median. Sometimes we want to talk about spreads, so standard deviation and some other deviations here. And then you've got minimum, quantiles, and things like that. This is a reminder for you. So when you look at the PDF file, you will see how they would work. Let me point that out. It's there, and so you've got the names of the functions. But let me tell you also a couple other function names that are convenient for exploration. We'll get to a place where we will be talking about validation. And there are times when you would want to sample from something, and there are functionalities available in R for taking samples. One of them is simply called sample n, underscore n. And then the parameter it takes is how many samples you would take. So for example, if I had the flights data set and I want to take a sample 5 out of it, this is how I would do it. And this is without replacement. That means you're taking 5 samples randomly out of it. And once you have taken one sample out, you will not put it back to get another one. So that's called sampling without replacement. And there are times, and there are statistical reasons when you would want to do with replacement. There is a function for it. It's called sample frag. And then you could say in one of the options you would give in its parameter list whether replace is allowed or not. And in this case, when you say true, replace is allowed. The sample with replacement typically works with how much percentage of the original data you want to sample. In this case, this example shows you what it is like when it takes 25% of it. All right. I know, I have walked fast, and I know you have the R Markdown file, and I also know that you've got the PDF, and you can go through this one on your own. So these are some demonstrations. Relational data is the next topic. And I'm going to be going from here to these other notes that I have left you with. The other notes I have left you with is an extension of this. If we get there, we will get there. If not, then you follow me along with this one and we'll be fine. Okay, relation is a word that you know very well, right? So you have, in the context of data sets now, it's very rare that you have something that you're working on and everything that you need is in one data set, in one data frame. Typically, what will happen is you have one data set in one data frame. Let's call it a data frame. And then you've got a related data somewhere else. And these two have to be worked together to explore something or to work out with something. So this is where the word relational data comes, and the word relational databases is an entire field. of you, I think a good number of you might have taken a relational databases class. And when you do that, what you have in mind is a database is usually you have entities, and these entities have to be modeled in a certain way for things to be consistent. So you've got a way to get up to the place where they are formulated as relational databases. And so the discussion we have had last time about TidyR has connection, as I pointed out. But what I want to tell you now is where you're not the person who is designing how this one will be organized, but you have a need that would make you work with data that is related. And they are in different places, and you want to manipulate them. You want to work with them in tandem by having to join them, by having to find out what this one is available and then the other one is available. So this is how you would work. So you have to typically work with multiple tables of data. And so your exploration may require you to explore them, to answer questions that you are interested in by having to combine them. And so this is called relational data. And you may already have, it might have come to your mind, or you might have seen, if I'm going to work with two tables and I want to relate them, then there must be a way for me to say how this table is related to this table. And that relationship is usually defined by something called a key. What is the unique identifier for an observation in a table? That will help me get how this table relates to this other one. And so that's the point we will get to in a second now. And so we'll be looking at, once we have identified those joint keys, we will be working with how to join them. And there are different verbs, just like we had in the DPlayer discussion earlier, where we had verbs, we have verbs here too. And we want to sometimes work with joins that would change what the original ones would be. They are called mutating joins. Sometimes we have got things that we combine between tables, and what the result would be is filter. So we had original two tables, we have joined them in a certain way, and the result would be a filtering. And you remember, a filter is something that would give me a subset of the rows. Select is a subset of columns, rows, and filter is a subset of the rows. And so there are joins that would mutate, there are joins that would filter, and some of the joins are just simple set operations. And that is where our next lecture, the Word file, would come in. But we're going to stay with the New York data set for a second. And let me clear this up for a second so that you can see. The New York flight data set has got multiple tables. One of them is called airlines. This helps you look up the full carrier name and its abbreviated code. Another one is called airports. And this would tell you the airport, and it is called by the FAA code, if you know that. Well, these days we don't fly, but you may remember what they're called. I'm trying to remember what the Pullman Airport's FAA code was, but I don't remember it now. And then you've got something about the planes. It is identified by its tail name. And then there's a table for this data set called weather, which gives you the weather in New York. If you look at this is based on chapter 13 of the R for Data Science book, by the way. So you remember the relational data discussion was, the data transformation was chapter 5, and then the TidyR discussion was in chapter 12. This is in chapter 13, I think, but I have left the note at the very end where you may find this one. So there you may find the data set even updated now to include this weather, not to be just about New York airport, but give you a chance to know what the location of this other one was so that you could get more weather information. So I have used this one on a slightly old one, but it still works, and it has worked on this one when I demonstrated. So we have these tables that I run through now. Flights is connected to planes via a single variable. And if I have a flight and I wanted to know, get information about the plane, the way I connect them is using the tail num variable. And flights is connected to airlines through the carrier variable. Flights is connected to airports in two ways. One, by looking at the origin and destination, or by looking at a number. Again, I think in one of the places there. And flights is connected to weathers via the location and the particular date when this one is happening. So when you have multiple tables like this and you have a way they connect, you have this notion of keys. This is where your relational databases knowledge would come. And this is the way to understand it is what is it in a particular observation that is able to uniquely identify it. And so if it is, for example, an airport, then the FAA code will be a unique identifier for it. Sometimes you may find this one, and I'm going to talk about something that's not written in these notes now. You may be surprised to find out that there isn't actually any unique identifier given for a data set. You may have whatever it is variable that you may choose or variable combinations you may choose, and you were to use the count operation I showed you earlier, or the n, how many things you have, you may find out that every single one of them has got more than one. And so you would be disappointed to lack a unique identifier for an observation that you could choose from the variables that are available, whether you pick one or use a combination. And that is frustrating sometimes. And so when that happens, you'll have to create your own. And you might have done that in other occasions when you have to work with the data set. And so you've collected things, there are different variables, but there are repetitions, but there are different incidents. And so one way you do is you have an ID that you would just show like the row number, for example, but you should be careful because sometimes you may change the order and you may have reasons for changing them. But let's say that you've got some way in which things were entered, and so the unique identifier for your observation will be something you create as an ID. But most of the time, most data sets have a natural thing that would be either one or a combination of things that could serve as a key. So you've got this notion of key, and so you can connect now to different variables, to different tables by using these keys. The other lecture that I would, or the notes that I would go to, will show you different kinds of joins, the one that I just outlined, mutating, filtering, and set operations. But what I want to show you here is a bit of a magic. And this is the place where I want you to use part of your lunch break now, after you've had your sandwich, 15 minutes, do what I would show you here. Let me first tell you what there is. You can work, and the way I described now, if you're familiar with databases, you would see that it has got some kind of relationship with relational databases indeed. And so you may be already thinking in your head that you want to actually work with databases, things that are stored as databases somewhere, but you want to bring them into R and think of them as data frames and work with them like what you would do with DPlayer and things like that. And so R and DPlayer in particular has a way to connect to databases and work with them. And they could be living somewhere else. They could be living, they're not in your R studio, in R session that you're working, it's somewhere else. So you can connect. And there are different databases that are supported by R for doing this. And one of them is called SQLite, and some of you may be familiar with it. And so this chunk of code here goes there, and I probably should have put this mydb.sqlite. That is not available on Blackboard. Now that I see it, now I know there is a FIV file that should come. Okay, we've got 4. Chris has walked us through 2 are RMD files and 2 are derivatives like Word file and PDF file. But this particular one, to run successfully, if you were to run it, you would need this mydb SQLite 3. That's the database. And so I have it on my computer now, so it will run fine, but it will not for you. So when this is over, I will go to Blackboard and post this one in those lecture material on September 21st. So know what you are up. If you're running it now, you may not. So if you look at what is happening here, you need to install that, the RSQLite package, and then you'll now have access to connect. And the first time I saw this one, it was kind of very interesting. It's pretty powerful that you're going to some database and getting it, and from now on, you're going to do your select, your arrange, your connecting with flights, you can join and things like that. Those sort of things that you see here will happen, but you did not need to do much other than having to remotely access that database is what this one is showing you. Okay, let me show first if this one, okay, so I have got some problems, it says. But I did go, let me see. But it worked out here and it connected. There was a complaint I got. Okay. All right, this one worked yesterday just fine. But this is the file that you would need. Hopefully you will not be needing to reinstall your R. I'm going to cancel this one. But it will connect to that database and give you results. Okay, so that was the last portion of this one. I'm going to stop sharing this and talking about the join parts. This one you will successfully run once you have the the file that I called mydb SQLite file. Right, I'm going to stop sharing this and then go to that other one in the remaining 5 minutes I have very quickly, but let me see if anybody has got any questions for me. Okay, it looks like most of these things that I see here is about, still about yesterday's AB, and it looks like many of you haven't watched, and I haven't, by the way. Let me open up the other file I want to open, see if I can very quickly walk through that. Actually, I could share the same R file I was sharing, and you could see, you could still see the R Markdown file I have because I have it there. This is the place where I want to show, and so I can just as well do this. But does anybody has got a quick question for me? Okay, so the type of joins you would want to do are 3 types. So the first one is a mutating join, and you could either have an inner join, which would take key combinations between 2 tables, and it would match up them, and then it will copy. It will copy all variables that are on the 2 tables. That's what an inner join would do. So in this case, when you run this, you will see there is a very simple example that has got only 3 entries in one of the table and 3 entries in the other one. So the first here has the key has got 1, 2, 3, and the second one has got 1, 2, 4, and so they match up in 2 places. And so the inner join is going to have to make this make them come like this, and then you get a result that is an inner join of the 2. Let me see if I can display the results here. I should have probably done this first for this to work. Yes. And now I can do this. Here we go. So the X1 and the X2 were the places where they matched, and the table is joined. That is an inner join. You could do a left join, a right join, or a full join. And the result you would get would depend on what you have done, whether it is a left or a right and the matchup, and you would see what it will do with when values are not known. Filtering join has got 2 of them. One is called a semi-join, which keeps all observations in X that have a match in Y, and an anti-join does the opposite, drops all observation in X and keeps the one that have a match in Y. And if you run this for the particular data set that I showed you, here is the place where you have a semi-join, and here is a place where you have an anti-join. Much like the joins, whether they are mutating or filtering, you could do set operations, intersect, union, set difference, and these things are things that you would know. What you will notice here in terms of syntax is each one of these set operations would take 2 operands, and the first and the second, and the result will be whatever the set operation is demanding, intersection, union, or set difference. And so you've got this example. The rest of the code shows you, this was a simple example with 2 or 3 entries each. The rest of the code shows you for the New York flights data set that I had described in the first part. And now you can work with things that are a little more interesting and have got some more functions. Okay, I know this was the place where I said I will be rushing, but you've got both of these files available, and you've got my guidance, and I'm going to be stopping here and see if they have any questions for me. Any questions?
I asked a couple of questions in the chat there. Inner join, I think, is, I think this is correct. Basically, just one of the tables needs to have a key, right? You basically have a common variable and then join, and then one of them has to have a key. But The other one is not a key.
Yes. So you've got what is called the primary key and the foreign key, right? So what is available here? So matching up them with the keys is what you need.
Right. Okay. Okay. Thanks.
Any other questions? So they should be self-explanatory. So the connection to a remote database part may make you struggle with R and have things to work on the R Markdown file I've told you, but the rest of the two files should be self-explanatory. Okay, the topic for Wednesday and for the remainder, we'll use 3 and 4 lectures would be data visualization. If you do not have any questions, then I'm going to stop here. It's 10 o'clock and I will see you on Wednesday. Be sharp and we'll start on time then.